War in space is inevitable, and with each passing year, it becomes more likely with each passing year as many countries are building up their space-related military capabilities. Today, the military space industry market is estimated at about $740 billion, and by 2025, it will surpass the $1 trillion mark. But when people talk about war in space, they usually imagine spaceships, infantry, and laser rifles. For now, that's still a long way off. But the first space war has already happened. It took place 30 years ago on Earth, and the next war will definitely extend into orbit. The struggle for supremacy in space began about 60 years ago. The main rivals in the space race were the US and the USSR. Space was one of the symbols of a superpower along with nuclear weapons, and the rivalry for supremacy in orbit was an element of the Cold War. The start of the race was marked by the launch of the first artificial satellite, Sputnik 1 by the Soviet Union in October 1957. From that moment on, military activity began in space. The successes of the US and the USSR in space caused mixed feelings around the world. On one hand, it was a sign of new opportunities opening up for humanity. On the other hand, because of the Cold War, the appearance of weapons of mass destruction in orbit was only a matter of time. And it happened. In the summer of 1962, the United States detonated a nuclear warhead in space at an altitude of 400 kilometers as part of Project Starfish Prime. The explosion created a temporary radiation belt around the Earth, which disabled several satellites, including the British Ariel 1. World leaders began to realize what kind of catastrophe nuclear weapons in orbit could cause. In 1967, the United States, the United Kingdom, and the Soviet Union signed the landmark Outer Space Treaty. The document banned sending nuclear, chemical, and biological weapons into space, as well as building any military structures or devices in orbit. The treaty also declared space to be the property of all humanity, open for exploration. Thanks to such initiatives, space has not yet become a large-scale theater of military operations. On the contrary, it is actually an important arena for nuclear deterrence. By 2021, there are about 6,000 satellites in space. Of these, more than 2,600 are operational. They provide communication, observe the Earth, monitor the environment and border security, and are responsible for the navigation system. At the same time, at least more than 300 satellites exist solely for military purposes. The rest of the space objects are essentially space debris. More than 50 active satellites, both commercial and governmental, are controlled by NATO member countries. Satellites make it possible, in particular, to ensure the accuracy and striking power of strike forces and assets. And the first space war took place 30 years ago, in 1991. It demonstrated the real importance of outer space for the military. That was when the U.S. campaign in the Persian Gulf began. Although there were no direct combat engagements in space, the American operation was greatly aided by the Global Positioning System, GPS. It was first used during the Vietnam War. Without orbital eyes, it would have been much harder for U.S. troops to navigate, communicate, and command their forces in the deserts of Kuwait and Iraq. Massive artillery barrages, the so-called steel rain, would also have been impossible without GPS. The main contenders for leadership in space remain the US, China, and Russia. Take such an obvious indicator as the number of satellites. These countries have, respectively, 1,327, 363, and 169 satellites. But it's not just about satellites, so let's take a closer look at the leading countries. In 2020, the budget for the Space Force was only $40 million, and already in 2021, they will be funded with more than $15 billion. The sharp increase in funding is one of the key signals that symbolizes the beginning of Star Wars. The overwhelming majority of the Space Force budget will go to research, development, and implementation of new technologies. There's $10 billion. The allocated funds will be divided between operations and maintenance, as well as the supply of new equipment. For example, $1.8 billion will go toward purchasing 2 GPS-3 systems from Lockheed Martin, which have improved jamming protection. These same units are 3 times more accurate than existing GPS systems. The United States also has the overwhelming majority of active satellites, 1,327. China launched its first satellite in 1970, and initially it did not pose a threat to the United States or the Soviet Union, who were already actively exploring space at that time. However, as the economy grew, Beijing's ambitions also increased. In 2003, China effectively declared itself a space power by beginning manned space flights. And already in 2007, Beijing demonstrated that it was capable not only of peaceful, but also military competition in space by destroying its old weather satellite with a missile, which was orbiting at an altitude of over 850 kilometers. Before that, Beijing had made 3 similar attempts, but all of them were unsuccessful. This satellite, weighing a ton, exploded, creating at least 100,000 dangerous pieces of space debris. We'll show you the damage caused by this debris a little later. Almost all Western countries, including the United States, condemned China's actions. However, Washington also possesses such weapons, and similar tests were conducted by Americans back in the 1950s. That makes the criticism rather hypocritical. It was mainly due to the emergence of another threat to American equipment in space, as well as the creation of space debris. But despite the protests, China continued to test anti-satellite weapons. Now, they may be better trained at this than anyone else. Today, China has various carrier rockets, all kinds of satellites, launches robotic interplanetary probes, and has programs for exploring the Moon and Mars. During the implementation of the first program, Beijing managed to achieve an impressive result by landing a spacecraft on the far side of the Moon. They were the first in the world to do this. Beijing also announced plans to build a manned base on the Moon by 2029. It was this episode of China's activity in space that forced the administration of the American president to actively develop the United States military and civilian space capabilities. We are now participating in a space race, just like it was in the 1960s. China became the first country to land a research probe on the far side of the Moon, which demonstrates the country's desire to take a strategic leadership position in lunar exploration, said former U.S. Vice President Michael Pence. The Strategic Support Force of the People's Liberation Army is responsible for Beijing's military activity in space. They were established in 2015 as a result of a major military reform. They combined virtually all aspects of military space operations, becoming a unified command center for space launches, supporting the Army on Earth, as well as providing satellite communications and intelligence. Discussions about the need to create space forces in China began as early as the 1990s. Beijing saw the operational capabilities that Washington gained thanks to space and GPS. Therefore, as early as 2000, the Chinese military, among other things, obtained their own navigation system, Beidou. Our country is still a spacefaring nation for now. Although soon, India might push it out of the top 3. We'll talk about it a bit later. Moscow participates in missions on the International Space Station. It launches rockets from the Baikonur Cosmodrome. Until 2020, the United States used Soviet and Russian launch vehicles, but due to SpaceX's technological breakthrough, Americans plan to completely stop using Russian services. In 2021, all of Russia's space achievements are inherited from the Soviet Union. Flights to the ISS are carried out thanks to the Soviet Soyuz and Progress launch vehicles. For example, Russia's space program for 2016-2025. The ultimate goal is approaching the Moon for full-scale exploration, as well as landing people there in 2030. China is aiming for 2029. The US is aiming for 2024, or, at the latest, 2028. But it's already been 5 years since the program was approved and started, and Roscosmos still hasn't fulfilled a single item in the plan. This means that the deadlines are already being pushed back by at least 5 years. Moscow is trying to fix the situation by creating new projects, but they become outdated even at the planning stage. The Angara A5 rocket project and the new Soyuz 5 and Soyuz 6 rocket projects became outdated even before serious development began. They're being developed from the Soviet medium-class rocket Zenit. It was created back in the last century. There are also seemingly breakthrough projects, but their prospects and feasibility are shrouded in secrecy and uncertainty, so it's quite difficult to evaluate them objectively. For example, there is a program called Zeus. That's the name now given to what was at different times called the nuclear tug, the transport and energy module, and Nuklon. The Russian Design Bureau Arsenal presented its model at the International Aviation and Space Salon in 2021. The essence of this program is a nuclear reactor in space that is capable of generating half a megawatt, that is, 500 kilowatts of electricity. For comparison, the current ISS has just over 70 kilowatts available. According to the ambitious mission plan, one payload module will detach near the Moon, then another one near Venus, and then the spacecraft will head to the Jupiter system to study the icy shells of its moons for signs of life. A structure weighing more than 30 tons will do all of this in just 50 months. At the same time, the spacecraft is dual use, and there is already news that it will be used not only in distant regions, but also in Earth's orbit. Roscosmos solemnly promises that it will begin carrying out the mission in just 10 years because the tug's preliminary design, costing a mere 4.2 billion rubles, is due in just 3 years. In addition to the US, China, and Russia, several dozen other countries are also participating in the space race. For example, the United Kingdom is only slightly behind Russia in the number of satellites, with more than 130 satellites. Japan is among the top 5, with around 80 active satellites in its arsenal. These countries also have their own space programs. Meanwhile, Russia is closely followed by India. In 2019, it declared itself a spacefaring nation. It was that year when the Indian military managed to shoot down a satellite in low Earth orbit. New Delhi is actively preparing to conduct independent crewed missions on its own spacecraft. In 2021, they will carry out unmanned test flights. In 2022 and 2023, with a person on board. The country has long-term lunar and Martian programs. And although in 2019, the Indian module crashed while landing on the Moon, at least it made it there. One of NASA's current priorities is the Commercial Crew Program. Its goal is to stop using Russian Soyuz spacecraft for flights to the ISS. The main contractors are SpaceX and Boeing. The program's success came in November 2020. Elon Musk's company delivered 4 astronauts to the ISS on the private crewed spacecraft Crew Dragon from American soil. The private sector is also being brought into military space programs. Many private corporations work for the Pentagon. De facto, this means that companies involved in the industry have long been participants in the militarization of space and the future space war. The leaders in the defense aerospace market are Boeing, SpaceX, Blue Origin, Lockheed, General Dynamics, Airbus, Northrop Grumman, and United Technologies. Most of the revenue of these companies comes from military and civil aviation. However, all of them are also involved in the development, production, and maintenance of both civilian and military spacecraft. If we consider revenue exclusively from space projects, the market leader is SpaceX. Moreover, in the first half of 2021, for the first time in history, a private company surpassed any country or space agency in orbital launches. In the first 6 months of 2021, SpaceX carried out 20 successful launches. In second place was China's State Space Corporation. Roscosmos was third. Moreover, Elon Musk's company also became the leader in launching people into orbit, having already delivered 4 astronauts to the ISS. Here, Russia and China shared second place. Technically, each had 1 launch, but the Crew 2 mission's crew consisted of 4 people, while Russia and China each delivered 3 cosmonauts. And moreover, when it comes to the number of satellites launched, SpaceX has no equal at all. 930 spacecraft, 700 of which are Starlink satellites. But here, another number is much more important. In the first half of 2021, SpaceX put more than 230 metric tons of cargo into orbit, while the rest of the world combined launched about 175 tons. And that's just for the first half of 2021. Space exploration isn't only about Musk. Other billionaires are getting actively involved in spaceflight, though not as extensively or for as long. Blue Origin, owned by billionaire Jeff Bezos, and Virgin Galactic, owned by billionaire Richard Branson, are pursuing the same goal without the involvement of a state corporation. They send tourists on space excursions and conduct scientific experiments in suborbital space when the spacecraft cross the boundary between the atmosphere and space, but do not enter Earth's orbit. The pioneer in this was the founder of Virgin Galactic, billionaire Richard Branson, who flew into space with several other passengers on July 11, 2021. His rocket plane VSS Unity rose to about 90 kilometers above sea level. When the spacecraft remained at this altitude for a few minutes, the tourists were able to experience weightlessness, after which the vehicle began its descent and successfully landed on the runway of Spaceport America in New Mexico. The Blue Origin spacecraft, unlike its competitor, is capable of ascending to more than 100 kilometers. On board, just like in VSS Unity, it can carry 6 people who can observe what is happening outside through the portholes. However, there are fundamental differences between the two flights. Virgin Galactic uses a carrier aircraft, which at a certain altitude detaches the spaceplane with the tourists. The spaceplane then ascends into suborbital space using its own engines. Blue Origin has a completely different approach. Bezos's company has developed a carrier rocket with a pressurized passenger capsule. The capsule separates from the rocket at an altitude of about 40 kilometers. After that, the carrier rocket lands on its own, while the capsule continues to gain altitude by inertia and enters space for a few minutes. The capsule returns to Earth with the help of parachutes, firing its braking engines before landing. An important difference between the New Shepard spacecraft and the Virgin Galactic spaceplane is that the entire flight is fully automated, whereas the VSS Unity is piloted by pilots. Thus, Bezos's mission became the first uncrewed spaceflight, with a crew made up entirely of civilians. Virgin Galactic and Blue Origin received official permission for crewed launches. According to Richard Branson, at least 600 people have already bought tickets for flights on his spaceplane, including Elon Musk. Each ticket costs $250,000. Blue Origin's customers will have to pay more. Elon Musk also plans to enter the field of space tourism. At the beginning of 2022, his Crew Dragon spacecraft will send travelers to the ISS. Before that, 7 people had visited the station as tourists, all of whom were delivered by Russian Soyuz spacecraft. Militarization of space has continued since the early years of exploration. Some incidents make us think that countries are not just arming themselves for battles in space, but have already started a full-scale war for it. And the main object of rivalry in this war is resources. In April 2020, the President of the United States signed an order allowing American companies to develop and extract resources on the Moon and other celestial bodies. Russia and China immediately accused the United States of violating the Outer Space Treaty. Moscow called it an aggressive plan to seize the territories of other planets. Beijing and Moscow reminded the world of their proposal to adopt a treaty on the prevention of the placement of weapons in outer space. The document would not only prohibit the placement of any weapons in space, but even threatening to use force against the space objects of other countries. Each of the 3 countries possesses ground-based anti-satellite missiles. However, the countries are also developing a new type of space weaponry. For example, in America, American intelligence claims that China and Russia possess laser weapon technology capable of disabling satellites. Russia and China are also actively using and testing garbage collector satellites. Their civilian use is for capturing debris. Their military use is for capturing satellites. China, according to Washington, has already demonstrated the ability to maneuver such devices in space, approaching other satellites. Russia is also testing a similar technology. In 2020, the Russian Federation launched the satellite Cosmos 2 into orbit. An object separated from it and moved toward another Russian satellite. Moscow says it's a small spacecraft, while the US claims it was a projectile. Before that, Russia also practiced maneuvering satellites in space. In 2017, they operated their spacecraft near an American satellite. It seems the incident happened again. Russia launched a satellite that began actively maneuvering near a US government device. And it is quite likely that it had weapon-like characteristics.
Характеристиками оружия.
It seems that one of the realistic examples of future space wars will be a scene like this from the series Space Force. A Chinese satellite approaches an American device and takes it apart for parts. But even in these comedic scenes, the wings become dangerous space debris, and we'll talk about that a bit later. In general, when you hear the words space war, images from Star Wars and other blockbusters usually come to mind. For example, in the 1970s, the USSR launched the secret military space station Almaz into space. What made it unique was its equipment. They installed a 23mm rapid-fire Richter cannon on Almaz. Eventually, the project was abandoned due to its high cost. But this case clearly demonstrates how space wars were imagined in the past. Nowadays, there are no plans to install machine guns on spacecraft. The main focus is on two areas: strengthening satellites and developing anti-satellite weapons. After all, any satellite can be considered a weapon and become a target during war. But there's a nuance here. The use of anti-satellite missiles creates space debris, which can later lead to the Kessler effect. The debris collides with other debris and creates a domino effect, making low Earth orbit unusable for spaceflight. You might wonder what harm a small piece of man-made debris can cause. Lost bolts or pieces of plastic? Here's an example. In the photo, you can see the result of a random collision between a 2mm thick aluminum panel of the ISS and a piece of plastic traveling at 7 kilometers per second. Or, to put it in car terms, that's just 25,200 kilometers per hour. Or here's a fragment of a 4-centimeter thick panel, grazed by a 6 by 12mm bolt flying through space at a speed of 6 kilometers per second. And if the bolt were moving at a speed of 10 kilometers per second, its direct impact with the ISS or a satellite would be equivalent to the explosion of an anti-tank shell. The scale of problems that hypersonic space debris can cause is shown in the movie Gravity. Given the photo of the ISS puncture, that's hardly an exaggeration. Do we, as a global civilization, have the ability to avoid repeating in space the mistakes we've made on Earth? After all, a war that reaches space and leads to the destruction of satellites will radically change life in the digital age. Or maybe that's for the best? Technological competition, even in military space, is what drives space progress ever forward. Let's discuss these interesting and complex questions in the comments. Thank you for watching this episode, and see you in future videos on our channel.